As a school, we undertook the Literacy for Learning training a few years ago, and as I was sitting there and working through the training, my head was just going 1,000 miles an hour, just thinking about how I can use this in maths and how the structure provided me for in maths. Hearing about the training and hearing that it was a functional grammatical training as a maths teacher was sort of like, I'm not really interested in this. This is something that I don't really want to do. But once I had done the training, once I put the training in place and could see how I could use that in maths, it just made a lot of sense to do it that way. It hasn't taken a huge change in practice. It's been quite small changes that are having quite a big effect on the students as well. The biggest thing for me was the breaking down of sentence structure. It's not something that I was ever taught as a child or as a student. So really thinking about how to break down a sentence structure and how I could then adjust that for the maths context. Working here in Broadmeadows for quite a long time, I've worked with a lot of EAL students. And some of the EAL students come in with quite a good mathematical background. So you know that they can do the mathematics, you know that they can do the multiplication or the division. They just don't know what to do and when to do it. How long have you been speaking English?
I started maybe the first term in language school in Melbourne, which was a year and a half ago. I don't use it much because at home I just use the Syrian.
Francois, you're in my maths class this year, and we've been working on understanding questions and understanding language. How, as an EAL student, how have you found that?
At first, when I was trying to understand the question, but when I asked for help to understand it, it was simple, but I just couldn't understand what I should do, what the question is asking me to do. Yeah, but now it's much easier because it was just simple words I need to understand, and I'm good now.
Really trying to get them to understand the questions is the key for that. They need to understand what they have to do and how it has to look before they can really sort of get stuck into the maths work. We do colour coding in the questions in maths, and the reason why we do that is it provides a structure for the students to use to then understand the questions further. So most maths questions have three parts. The first part is the process, which is the verb, which is what the students have to do. The second part is the participants. We colour that red, and that refers to what the students are doing it to. So whether it's the adjusting this or changing that. And the last part we colour blue is the circumstances. What does the question need to look like? What does the answer need to look like? Whether it's in certain units or whether it's a picture or a diagram or a graph. So how does the question actually have to look at the end? So participants, processes and circumstances. So does somebody want to try and tell me what the process is? What are we actually going to be doing? Michelle? Find. So find is the first part. That's our verb or our process. Okay? So what's what we're going to do? We're going to be finding. What is it that we're going to be finding? Isaac? The circumference. Good. The circumference of the following circles. Okay, which circles are they referring to? Fefo?
A and B.
A and B. Okay, so it doesn't say the circles on the right, but they're the only circles on the page. So the last one we're looking at is the circumstances. How does the answer have to look? Bassam?
Two decimal places.
Two decimal places, good. Is that it, just to two decimal places?
Using pi.
So using the value of pi on the calculator. So we know that pi can be used as 3.14, okay? But we want to use the value of pi on the calculator. So you need to use the actual pi button on the calculator to get the correct answer. Okay? It's really important that for the answer to be correct, you must follow both circumstances. Okay, so we're looking at correct to two decimal places and using the value of pi on the calculator. So you have to follow both of those circumstances for the question to be marked correct. Breaking the questions into those three parts really helps the students understand. It gives them a structure where they can use that in other subjects as well, whether it's science or humanities. Breaking down those questions and doing it across the whole school means that the kids have an understanding of what they're doing and are able to use that skill or that strategy across all their subjects. How have you found some of the other language skills that you've been learning through your language class?
When understanding the question is easy to do, and not just in maths, in anything, because I understand how to do it, but it's sometimes hard to understand what to do. So the language helps a lot, and not just maths and any other subject.
So having the students understand the language and what they need to do for certain questions, it saves a lot of mistakes in the work and allows you to work through the questions and the content quicker because the students are understanding the language behind it. So for me, it's going a little bit slower to work quicker at the end. When you work through the tests and you see questions that historically in the past students have got wrong because they haven't understood what they needed to do or which parts of the question refer to which parts, and seeing students actually have highlighted the question using the colour coding and understood the question and worked through. So students really making that change in their practice, I guess, is the proudest moment for me, and seeing that they're using these strategies and that they're finding it really helpful and that it is making a big change on the results. We're comparing two different questions here. Find the circumference of these circles corrected 2 decimal places. Use a calculator for the value of pi. So you can tell me what the differences in these two questions are.
For question 5, you need to find the circumference. However, for question 8, you need to find the perimeter.
Perimeter. So the first one talks about circumference, because we don't call it the perimeter of a circle, we call it the circumference of a circle. But when we have a sector, we're looking for the perimeter. Okay? So that's the difference in the two questions. What does this mean for answering the question? Are they the same? Are we going to answer them the same way? No. So it's really important to understand that they look very similar, okay, but we're not even going to answer them in the same way. The first one, we're going to use our formula, pi times diameter, to get the circumference. The second one, we need to do that for the outside line, but then we also need to add on our diameter in the middle to find the perimeter. So it's about understanding the questions and understanding that these are different questions. They'll come straight after each other in the textbook, but understanding those differences in the question and being able to work through those differences to make sure that we're doing this the right way.